So it may be of anything. So what I'm trying to tell you is R1 and R2 are directly connected. So that is going to be the series combination. I1 is equals to I2 is equals to I combination is equals to I, where V combination is equals to, that is the voltage is equals to V1 plus V2, and I can write voltage is equals to I into R, right? From this relation we can write V is equals to I into R. Now here combined current plus series resistance, I can write them as, since the current is same for both the resistance, I'm taking it as I. Now I R1 plus I R2. All right. Next comes the resistance. The combined series resistance is equals to R1 plus R2. Alright, now this is all cleared about the series resistance. What is series resistance? They are connected without any gaps or anything. They are just connected in a simple one way. Now the current in the series resistance is same. Voltage is the combined voltage V1 plus V2. It has each particular voltages. So what I'm telling, resistance is different, voltage is different, but current is same for whatever the resistance are present. Now coming back to the parallel resistance formula, 1 by R parallel is equals to 1 by R1 plus 1 by R2. Fine. Now you can observe there's a two circuits like kind of combined. Now here in the first line we can observe only the R1, and the second line we can see the R2, right? Now there are ending points, or I can say the joining points or something like that. Here the A and here's the B. Now I'm just putting it as A B, but I can also make sure I can just give it as C D or E F, anything. So A B again, and again this is A and B. According to the direction of the voltage, I mean the negative or positive terminal of the battery or the voltage is given, the current is been directed according to that. Now here we can see there's R1 and R2 and there's a voltage. Now here the entire voltage passing through entire circuit is same, that is V1 is equals to V2. Now talking about the current is different. Why? Because we can see two circular loops. There's no on in the case of series connection we can observe only one circular loop, but in case of parallel resistor connections we can see two circular loops being interconnected. So the current passing through the circuits are a bit different. Here is the I2 and here is the I1. Fine. Now here we can write it as voltage is same, current is different, and resistance is different, right? So V1 is equals to V2. Current combined is equals to I1 plus I2. That is the current passing through the first circuit. If I name this as first circuit and this is a second circuit, the current passing through the second circuit is 2. It's a combination of both the current passing through the both the circuits. Fine. Now talking about the the if I want to substitute this in Ohm's law, V by R parallel, which is equals to V is same, right? So V by R1 plus V by R2. Now the V is been cancelled entirely here. If I take the voltage common, entire thing has been cancelled. What I get is 1 by R parallel is equals to 1 by R1 plus 1 by R2. Here also the same case, if the combination is same for the entire circuit, so I cancelled. So this thing. Now in questions, what thing is to be remembered is this: what happens in the parallel resistors and what happens in the series resistance. These things are very important to be remembered. That is what I'm trying to highlight here. Yeah. So this is all about the basic, idea of what's happening in the series and parallel combination of the resistors, right?